Previously, we showed that if you take the limit as x approaches any finite value a of the quotient of two functions, f and g, and that as x approaches a, these functions approach infinity, we can say that this equals the limit as x approaches a of the quotient of the derivatives of these two functions. So we have f prime of x over g prime of x, provided that this limit exists. So what we'd like to do now is show that we can do this if we have a being plus or minus infinity. So I'm going to erase this, and we have here, again, the functions f and g, and we are told that as x approaches infinity, f of x and g of x approach infinity. And we would like to show that the limit as x goes to infinity of the quotient of these two functions equals the limit as x goes to infinity of the quotient of these two functions' derivatives, provided that this limit exists. So let's take a look at the limit as x approaches infinity of f of x over g of x. Now I don't know how to handle x going to infinity, so I would like to make a substitution here so that x will go to some finite value. So I'm going to pick a new variable. I'm going to call it u. I'm going to let it equal 1 over x, because this way I can say that this is the limit as x goes to positive infinity. If u is 1 over x, u will be approaching 0 from the right. And let me look back here and do the reciprocal on both sides. So if I do the reciprocal on both sides, I know that x is 1 over u. So we have f of x, which is our 1 over u, over g of 1 over u. Well, as u is approaching 0 from the right, the insides of these functions are approaching positive infinity. And we know that when that happens, these function values are also approaching positive infinity. So we can do what we proved last time. We have the quotient of two functions approaching positive infinity. We know that we can differentiate the top and the bottom. So we'll do that. And we will say that this equals the limit as u approaches 0 from the right. Actually, I'm using u, so let me put this as u. So the derivative of f of 1 over u is going to be f prime of 1 over u, but then we will use the chain rule and multiply by the derivative of the inside function. Well, we'll start with the one on the top, so we'll multiply by the derivative of 1 over u, which is negative 1 over u squared. And on the bottom, we basically have the same thing. We'll have g prime of 1 over u times negative 1 over u squared. And these cancel out. And now we're basically done, but I will just put this back in terms of x. So I'll say that this is the limit. If u is approaching 0 from the right, again, x is 1 over u, so as u approaches 0 from the right, x will approach positive infinity. And we have f prime of 1 over u, which is x, over g prime of 1 over u, which is also x. So we've shown that this limit equals this limit, which is what we wanted to prove. And now let's see what happens if our variable is approaching negative infinity instead. So we have the limit as x approaches negative infinity of f of x over g of x. And this time we're told that as x approaches negative infinity, these function values are approaching positive infinity. So I'm going to, again, make a substitution. This time I'm just going to let u equal negative x. Bring the negative to the other side as well. X equals negative u. Well, if u is negative x, then as x approaches negative infinity, u will be approaching positive infinity. So I can say that this is the limit as u approaches positive infinity. F of x is, we have the negative u, over g of x, which is also the negative u. And we know how to deal with this because you can see that as u is approaching infinity, the insides of these functions are approaching negative infinity. And we know that as that happens, the function values are approaching positive infinity. So we can differentiate the top and the bottom by what we just proved. So we can say that this is the limit as u approaches positive infinity. The derivative of f of negative u is going to be f prime of negative u, but then we will remember the chain rule and multiply by the derivative of the inside function, which is negative 1. And on the bottom, we'll basically get the same thing, but with g instead. So we have negative g prime of negative u. And now I will firstly cancel out the negatives, and then I'll put u back as x. So I'll say this is the limit. Well, of course, as u approaches positive infinity, u is negative x, or x is negative u, so x will be approaching negative infinity. Let me write this down better. X is approaching negative infinity. We have f prime of negative u, which is x, over g prime of negative u, which is x. So we've shown that this equals this, which is what we wanted to prove.